As we have seen, we can use Fitch to create proofs for theories with equality by adding the equality and substitution axioms to our premise set. However, this is not the only way to go. Since equality is such a pervasive and important relation, it makes sense to treat it specially in our proof system. In this section, we're going to show how to extend Fitch to handle equations. And it turns out all we need is one axiom schema and one rule of inference. Our axiom schema is called equality introduction, or QI. It allows us to write down arbitrary equations in which the first term and the second term are equal. For example, without any premises whatsoever, we can write down equations like a equals a, and f of a equals f of a, and even non-ground equations like f of x equals f of x. Our rule of inference is called equality elimination, or QE. Equality elimination tells us that when we have an equation and a sentence containing one or more occurrences of one of the terms in the equation, then we can deduce a version of the sentence in which that term is replaced by the other term in the equation. In order to avoid the unintended capture of variables, QE requires that the replacement must be substitutable for the term being replaced in the sentence. This is the same substitutability condition that adorns the universal elimination rule of inference that we saw earlier. Note that the equation in the equality elimination rule can be used in either direction. That is, an occurrence of tau 1 can be replaced by tau 2, or an occurrence of tau 2 can be replaced by tau 1. For example, if we have the identity x equals b and the sentence hates of x, x, we can infer hates of x, b. We can also infer hates of b, x. And we can even infer hates of b, b. To see how these features help in proofs with equality, let's once again consider one of the problems we saw earlier in the lesson, namely proving a equals c from b equals a and b equals c. Here's the old proof with the two premises and 3 equality axioms and 5 steps of proof. And here's the proof in our modified Fitch system. We have our 2 premises and just 1 step of deduction. That's all that is needed. Here is the other problem we saw earlier. From f of a equals b and f of b equals a, we want to prove f of a equals a. Once again, we have our old proof. 2 premises, 3 equality axioms, 1 substitution axiom, and 5 steps of proof. And here's the proof in our modified Fitch system. Again, we have our 2 premises, and once again, just 1 step of deduction. Building things into our system makes for much shorter proofs. This exercise tests your understanding of Fitch with equality.